So in the previous lecture, we have seen, the chain rule, right, Mayan? Right? We have done
No, sir.
chain rule, right?
Right.
Okay. Now we see the implicit differentiation. Implicit differentiation. So let me tell you the situation. So here, you know, we have two cases. We consider two cases basically. So let's say the case one. I'm writing like this. The case one. Let you know. See what is the idea? Right? Actually, if I give you y as a function of x explicitly, right? I mean, if I put a y as a function of x, then you can immediately calculate. We can easily calculate dy dx, right, Maya?
Right.
Okay. So for example, if I give you y equal to, let's say, let me put here y equal to, let's say, x square plus 3, then you can easily calculate dy dx. So it will be 2x. Here, y is function of x, and suppose it is explicitly given. I mean, the directly given as a function of x. That case, we can easily calculate dy dx. Now, suppose, instead of having directly y as a function of x, suppose we have a relation between x, y, and we want to calculate derivative of y with respect to x. Okay, Maya. So how we do that kind of thing? So that I'm explaining here to you. So if you have some relation of xy, say it is f of xy equal to 0, then how we find dy dx? Then dy dx equals to, so here we assuming that y is a function of x, but it is not directly given. The thing that we have given the relation between x, y. So some equation of x, y equal to 0. Directly we have not given. For example, you can think that you have x square plus y square equals to 1. Okay, Mayan? This kind of thing. So you can easily calculate y. Y will be what? Square root of 1 minus x square, like that. So this is implicit, right? And this is, we have explicit form. We can write y as a function of x. But you can see some cases, we cannot separate y. I mean, we cannot write y as a function of x. So in that case, how we calculate the change of y with respect to x? That formula we call the implicit differentiation formula. So I'm writing here. So this will be minus, del f del x divided by del f del y. Mayan, clear?
Yeah.
Okay. And we provided that, del f del y, this not equal to 0 because it is in the numerator, right? I mean denominator. So it cannot be 0. This way we can calculate. Fine, clear? So let me write a question here. So for the case one, the example. So find dy dx where x cube y square plus y sin x plus 3 equal to 0. Mayan, clear?
Yeah.
Okay. We cannot write y as a function of x, but still we can calculate derivative. And so how we do? So first you have to identify f. So this is your function f, right? So here fxy is what? The fxy is x cube y square plus y sin x plus 3. Now we calculate del f del x. So del f del x will be what? Partial with respect to x. So del x of x cube y square plus y of sin x plus 3. So what should we get with respect to x? Y is constant here. So 3x square y square plus y cosine x. Mayan, is it okay?
Yeah.
Right. What is del f del y? So that will be del y of x cube y square plus y sin x plus 3. So what should we get? 2x cube y plus sin x. So we have del f del x, del f del y. So now what is dy dx? We know the formula is given by minus of del f del x in the numerator del f del x and denominator del f del y. If you want, you can write shortly this way, that minus of f partial derivative of x and below partial derivative of y. You know, it is looking easier than this, right? I mean, okay. So what?
Okay.
Yeah, what should we get? Del f del x is what? Put it here. 3x square y plus y of sin x, cosine x, and bottom we get 2x cube y plus sin x. So this is the dy dx form, right? So if you have, you know, a relation between x, y, and if you want to calculate dy dx, so that you can calculate by using this formula. Dy dx equal to what? Del f del x divided by minus del f del x, I mean minus fx divided by fy. Okay, man, any questions so far?
No, this is fine.
Good, nice. So let me tell you the case 2. Here two case we have to study basically. The case 2 is here. So let we have f. Now we have, let's say, a, we have a variable w. I mean z. Let's say that is a function of, so x and y. Suppose g is a function of x and y, but it is not directly, I mean explicitly not given. The relation of x y g that is given. Okay. So we calculate del z del x, change of x with respect to, I mean change of z with respect to x partially. So how you get it? So it will be minus of partial derivative of f with respect to x divided by with respect to g. Mayan, clear?
Yeah, clear.
Right. Del z del y, how you calculate? Minus, since you have del z del y, you have to rate, you have to take here f suffix y divided by f suffix g, provided that f suffix g not equal to 0, f suffix g also here not equal to 0, that way. So in the first case, it is implicit differentiation formula for function of single variable. I mean in the case when you know y is a function of x, then the derivative of y with respect to x is given by this formula. Now, if your function f, I mean g, is function of two variables, say x and y, and that case, we can naturally claim the partial change of g with respect to x, g with respect to y. So in that case, it is given by this way. Man, any question so far about this
No, I
case two?
don't have any.
Oh, okay. Okay. Now example. Here example. Let me write here. Find del z del x and del z del y for, let's say we have 3x square g minus x square y square plus 2gq plus 3yg minus 5 equal to 0. So here we have a relation between x, y and g. We want to calculate the partial derivative of g with respect to x, partial derivative of g with respect to y. So it is the second case, right? So the solution. First you write down your f function. What is f here? F is basically 3x square y minus x square y square plus 2 of gq plus 3yg minus 5. What we need to find out del z del x and del z del y? We need change of this with respect to x, with respect to y, with respect to g, right? Now f of x equal to what? Del x of this formula, 3x square g minus x square y square plus 2 of gq plus 3yg minus 5. So change with respect to x will be what? So then y and g constant. So this will be 3xg minus 2xy square, and the rest part since constant, so getting 0. So f of y is what? Del y of this expression, 3x square g minus x square y square plus 2 of gq plus 3yg minus 5. With respect to y, what should we get? Now x and g constant, minus 2x square y plus 3g. What should we get? Fg. Fg will be del z of this expression, 3x square g minus x square y square plus 2 of gq plus 3yg minus 5. So with respect to g, if we do, then what we get? It will be 3x square, then it will be 6 of z square, right? And plus 3 of y. With respect to g, we just take the change. Now we have fx, fy, fg. Now we put in this formula above what we have. So what is del f del x? Del z del x is minus fx, fz. So minus of fx is what? 6xz minus 2xy square divided by, this 3x square plus 6 of z square plus 3y. What is del z del y? You have formula minus fy, fg. So this is what? Fy is minus of minus 2x square y plus 3g divided by 3x square plus 6g square plus 3y. Okay, Mayan, clear?
Yeah.
Okay. So in this lecture, we have seen if you have a function y of the variable x, but suppose it is not explicitly given y is a function of x. Suppose there is a relation of between x, y given. and they asked find del y del x. How you do that? You have to apply the implicit differentiation formula. So how it is defined? Dy dx equal to minus del f del x divided by del f del y. So actually minus of fx by fy. So when you are taking dy dx mean minus fx fy. Now in the case 2, suppose g is function of xy, but it is not explicitly given g as a function of xy. There is some relation between xy and g, and you want to calculate del g del x del g del y. So how you calculate? You have these formulas. Using this, you can calculate del z del x equal to what? Minus fx divided by fy. Del z del y equal to minus fy divided by fz. So that we calculate. And what extra they can ask you? They can ask you. They will give you a point. I mean xy value they will give you and ask find del z del x del z del y at that point. So just at the end finally in the place you put x y and g. Fine, clear? Any question?
No, this is fine.
Very good. I think it's okay. So let me give you a table. Let me practice some problem here. Okay. Okay. Here it is. So so let me write here the question. So let's say w is function of xy and let x is the function of t and let's say y is the function of t. Okay. And let's say there is a given a table. Table is given by like this: g of 2, the age of 2, and g dash of 2 and age dash of 2 and f of x at 4 comma 3 and f of y 4 comma 3. That is given. So this is 4, this is 3, this is minus 1, this is 6, this is negative 5, and this is 7. So we have a table like that. Okay, man. Mine, is it clear? The table?
Yeah, it's fine.
Okay. Now here the question. Find. So we have function w. It is function of xy. X is the function of t. Y is the function of t. Now they asked find dw dt when t equal to 2. From this table we have to calculate. Okay, it is the chain rule, right, Mayan? You have here w. So here you have w, and then here you have x, and here you have y, and then this is the function of t. This is also function of t, right? So we calculate del w del x. We calculate del w del x, and then this is dx dt. Remember, I am using dx dt because x only function of t. Here del w del y, we have to calculate dy dt. Mayan, is clear?
Yeah, it's fine.
Okay. Now what is t, Mayan? T is given by 2, right? So t is 2. So for this t, you have to calculate x. So x equal to what? We know x equal to g of t means g of 2. So g of 2 is what? 4. Got it, Mayan? In the table.
Yeah.
Okay. What is y? Y equal to age of 2. Age of 2 mean what? 3. So for t equal to 2, x is 4. For t equal to 2, y is 3. Okay. Now see, remember, when we writing the derivative formula, what was it? It is basically, we know, del w del x into dx dt plus del w del y into dy dt, right? Now let me write down at t equal to 2. Then how this formula looks like? So del w dt at t equal to 2 mean you have to calculate partial derivative of w with respect to x at point, in this case, because here x function of t, y function of h, those formula are not given, only table is provided, right? So for t equal to 2, del w del x will be function of xy. So you have to calculate that at the point 4 comma 3, right? And then dx dt at t equal to 2. My unclear?
Yeah.
Yes, del w del y at again 4 comma 3 and into dy dt at t equal to 2. If you use your table, whatever you have in the table, that notation, then how it looks like? Del w del x mean partial derivative of x f with respect to x at the point 4 comma 3, and dx dt mean derivative of g at the point 2 plus, because x is the function of g, I mean x equal to gt, so dx dt at t equal to 2 mean g dash 2, right? Right? Now dw dy is what? W is the function of f. So this is with f with respect to y at 4 comma 3. Just same thing, I'm using the notation that you have in the table. Okay. Okay, man.
Okay.
Right. So this is this. Now put everything here. F x 4 comma 3. This is negative 5. Here it is. This into g dash 2. G dash 2 is negative 1. F of y. This is this at 7. So 7 into f h dash 2 mean here 6. So what should we get? We get 5 plus 42. So 47. Is it okay, Mayan? Clear?
Yeah, it's fine.
Very good. They can ask you this kind of question. Just you have to remember how we did this one. I'll send you the YouTube link. You can see the video again. Okay, there. Okay. I'm recording this. After class, I will send you the link, and you can see this lecture again in the YouTube. Okay.
Okay.
Right. So two things we have done in 8.5: chain rule and implicit differentiation. This, for when y is the function of x, you have this formula. If your the function g, if g is function of xy, then the change of g with respect to x partially and change of y with respect to g with respect to y partially given by this formula. Okay. And in the first lecture, we have seen the chain rule. There also we have seen two cases. Mayan, any question so far? 8.5 we finished. If you have any question, you can ask me now.
No, I don't have.
Okay. So let's practice one problem. Okay, Mayan?
Okay.
Okay, one thing I will ask you. So, do we get any more class before test?
Um,
I mean,
yeah, we
if
can have one or two more.
When do you have the test? After how many days?
Um, I have it on my Tuesday.
Okay, I think then we get your twist. I mean, okay, let me check. You already wrote here that you have. So your twist here. Okay. I think if I get one more class, then I can review 13.1 to 13.5, everything.
Okay.
Okay. So that I need basically. Okay. So we have more 10 minutes. So let's practice one problem. Okay.
Okay.
Right. So here one question. So so here find del W del S and del W del T using appropriate chain rule and evaluate each at the given values of S and T. So here is the question. W is the function of xy. It is given by, let's say, sine of 2x plus 3y, and x is the function of st given by s plus t, y is given by s minus t. Okay, Mayan? S equal to 0,
Okay.
okay, and t equal to pi by 2. This we try. So we have w function of xy. X is the function of s, y is the function of, s is the function of xt, y is the function of st, and there is particular value for s and t. So we have the second case, right? So we have here w, we have here x, and x is the function of s, and it is the function of t. Here it is y, and then y function of s. This is function of t. Okay, man. Oh, let me do again. Otherwise, it make you confused. So just the follow the step that I'm doing here. First, here write down w, and now check w is function of xy. So put here two branch. One is x. Here one will be y. Now x is function of st. So here two branch s, and here one branch t. Here you have s. Here you have one branch t. So if you calculate, then it will be what? Del w del x, and this way del x del s, del x del t, and this side del w del y, and then y is the function of s and t, so del y del s, del y del t. So if you calculate, what should we get? First, if we calculate del w del s, so one thing I tell you, you first calculate everything, whatever you have need. Actually, first you need del w del x. So del w del x, if you calculate, what we get? Del x of sine of 2x plus 3y. So what should we get? We get cosine of 2x plus 3y. So 2 into. Right, Mayan?
All right.
Okay. So if you use s and t, you put it here, then what should we get? We get 2 cosine 2 into x. X mean what? S plus t, and plus 3 into s minus t. So if you simplify, so what should we get? We get here 2 into cosine 2s 3s, so 5s. So 5 of s minus t. And now del w del y, what should we get? Del y of sine of 2x plus 3y. So what should we get? We get 3 of cosine 2x 3y. So then what should we get? We get 3 of same thing, we get cosine of 5s minus t, right? Fine, clear?
Yeah.
Okay. Now what is del x del s? This will be del s of s plus t. So it is 1. What is del x del t? That is del t of you know s plus t. So again it is 1. What is del y del s? Del s of s minus t. So that is 1. What is del y del t? So del t of s minus t. So this is minus 1. So we have everything. So now let me calculate del w del s. So what is this? We know by chain rule it will be del w del x into del x del s plus del w del y. We have to first we take this into this from here to here, and then from here to here, and it will multiply by this. So del y del s. So if you put, then what should we get? We get here 2 cosine 5s minus t into del s del s is 1 plus this will be 3 into cosine 5s minus t into this is del y del s is 1. So we are getting 2 cosine 5s minus t plus 3 cosine 5s minus t. So it is nothing but 5 of cosine 5s minus t. Right, Mayan?
All right.
Okay. So just you put t s equal to 0, t equal to pi by 2. So what we get? S equal to 0 and t equal to pi by 2. If you put, then we get del w del s equal to what? 5 of cosine 5 into 0 minus pi by 2. So what should we get? 5 of cosine minus pi by 2. We know cosine minus theta is cosine theta. So 5 of cosine pi by 2. So pi by 2 is 0. So 5 into 0. So 0. Fine, clear?
Yep.
So we calculate, yes, del w del s. Now similarly you can calculate del w del t, right? So del w del t formula you have to write. Del w del t will be what? Del w del x into del x del s plus del w del y into del y del s. Now we are focusing. So we are taking t. So here we have to put t, right? Why? Because t mean this into this you have to take, and this into this, right? Everything you put, and at the end you put s equal to 0, t equal to pi by 2, you get the answer. Got it?
Yeah.
So I'm not doing. So if you want, you can write down what 2 cosine of 5s minus t, and dx dt is what? Dx dt is 1, and then plus 3 cosine 5s minus t, and dy dt is minus 1. So what should we get? We get minus of cosine 5s minus t. So this is dw dt. So now you put t equal to pi by 2, s equal to 0 in this place. So you again get 0. Mind clear?
Yeah.
Okay. Okay. So when we meet again for the next class? Tomorrow are you available? Can we meet tomorrow one class?
Yeah. Tomorrow we can meet
Okay. See you then tomorrow. We go through from 13.1 to 13.5. All review. Okay.
for review. Okay, sure.
Okay. Okay. Thank you. Good night.
Can you send the link, by the way, to
Yeah, yeah.
the...
Just I'm sending you now after class. To
Okay,
lecture
sure.
link you can see in my YouTube channel. Yes. Okay. Bye.
Okay, sounds good.
Bye.
Thank you.
Thank you.
Bye.